Hi students, I welcome you all for the session. So this is the continuation of sets. So the part 2. So this is continuation of sets 2, sets part 2. So in this lecturing, we'll be going to discuss the topics uh, empty set. So we'll be discussing what is the meaning of a empty set and finite and infinite set. Finite and infinite. I will write I of infinite set. Equal sets. What is the meaning of equal sets? And we'll be going to discuss subsets. What is the meaning of subsets and universal set? Okay, these topics will be covered in this lecturings, and based on this concept, finite and infinite, empty set and equal set, we'll be solving some exercise that is 1.2, and these both based on these two topics, subsets and universal set, we'll be solving the exercise problem 1.3. Okay, we'll be going to discuss the first concept is the empty set. So what is empty set? As the name itself indicate that empty set it is a empty, means it does not contain any element. So within a set, so we are representing a set in the form of curly brackets or curly braces. So there is no element here, no element will be present, so it is called as an empty set. Okay, it is called an empty set. So the mathematical definition I'm writing here. So mathematical definition is a set which does not contain a set which does not, all of you note this definition. Okay, a set which does not contain any element. Any element is called the empty set. Okay, empty set. This empty set is also called by the name of null set or void set. Null set and or void set. I will give example of here null set. So suppose we consider two sets here. So two sets. So that here all of set x is such that is x is a student. Okay, here I am representing in a set in a builder form. So x is a uh, student in a school, student in a school presently studying in 11th class. Okay, presently studying in the 11th class. So this is an set. So in this example, in a school we can go to the school, and particular class also we can go to the particular class, 11th class, and we can identify a particular student in the class 11. And also it is possible to count all of the students in the set A. So this is an finite set. Okay, this is about finite set, and this set is contains an element. Suppose the example I'm giving here, the example I'm giving for an empty set here. So x, the set of all x such that is a student is a student presently studying in presently studying in both classes, in both 10th and 11. Okay, 10th and 11. So this is an empty set. This is an empty set. The reason is that, so how it is possible to study a student in both classes, in both 10th and 11th classes. So therefore it is the element does not contain a the set does not contain a element. Therefore we say that this is an empty set. So the empty set is represented by the curly braces, or we can represent by the symbol pi. Okay, by the symbol pi we can also represent a null set or empty set. So here this is the proper definition of null set, null or empty set. Okay, a set which does not contain an element is called empty set or null set or void set. Okay, and so some of few example we'll be discussing here. So these are the examples of null set. So in example 1, so the x is lies between, so x is lies between 1 and 2. So x is a natural number, and then a is empty set, right? It is right. Why? Because so there is no natural number is present between 1 and 2. Between 1 and 2, between 1 and 2. So there is no natural number is present, therefore it is an empty set. Okay, and so in example B, so here equation x square minus 2 and x is a rational number. So x is a rational number. If you put the value of x, then this equation has to satisfy. But here it will not satisfy. It will not satisfy because the rational number, which is in the form of ratio 1 by 2, 3 by 2, something minus 3 by 1 or minus 2 by 2. So this is a rational number which does not satisfy this equation. Okay, therefore it is a empty set. Okay, there is no rational number which present in the there is no rational number which satisfied this equation, therefore it is an empty set. And in example C, we prime number. So here example in example C, we seeing here prime number which is greater than the even prime number greater than the 2. So this is an empty set, we can say. Why? Because so there is no even number greater than the 2. Okay, there is no even number greater than 2. Prime number is not present. The 2 is only prime number present in the prime. 2 is only even number present in the prime. So therefore it is an empty set. So this is C does not contain element, so we can say as C is an empty set. So prime number is that it divides by is divides by its own number and by 1. That one number will be called as prime number. And example 4, here x square is equal to 4, x is a odd, so there is no odd number. So suppose you take odd number 1, 3, 5, 7. So if you put the value of x in this value is in x, so no odd number will satisfy this equation. Therefore, D is also an empty set. Understood? Now, next topic we'll be going to discuss what is the meaning of finite and infinite sets. Okay, as the name itself, we clearly define what is the meaning of finite and infinite set. Finite means with it is countable. Infinite means these are non-countable, means which are continuous. So these are continuous. So as in previous classes I have been shown, infinite set will be shown by this, like, okay, if suppose a set of natural numbers, so we'll be representing by 3 dots. So this means that it is infinite. It is infinite. Okay, and here I will give an example. So this example of A contains element 1, 2, 3, 5. So okay, this is finite. Okay, this is finite element which contains 5 elements here, and I will giving the example here. B is equal to A, B, C, D, E. So this is also finite set because it contains 6 elements. And suppose I'm giving here example C. So men living in different regions, men living in different parts of the world, men living in different parts of the world. So it is the number is very big here. The number of men in the world, it is big, which is big, but it is not a countless. It is possible to some it is possible to count. Therefore c we can say as some finite set, some finite set. Okay, understood. And now we'll be discussing the definition of okay, definition of finite and infinite set. Okay, so the definition is that a set which is empty, even empty set is also of empty is also finite set. Okay, so the empty set means pi, so or like this curly braces. So the empty set is also finite set. A set which is empty or consist of a definite consist of a definite number of elements. A definite number of elements. Number of elements. Number of elements is called finite set. Is called finite set. So otherwise, otherwise it will be called as infinite set. It will be called as infinite set. Okay. This is the definition of finite and infinite set. Let's we see the example of finite and infinite set. Is let W. So here W means a week. So week is consist of how many days? 7 days. So the W is finite set. And let S be the solution of the equation. This is an equation, and the solution of equation is finite, because if we are solving this equation, we'll be getting a set of -4 and 4. Okay, and if you put x value -4, then will be here 0 will be get, 4 will be put value, then 0 will get, because -4 square is positive number. And third example, let G be the set of points on a line. So G set of points on a line, we don't know particular how many lines are, how many points on the line. So therefore, it is, we can say that G is a infinite set. G is a infinite set. So one here we know about uh, real numbers. So because real number contains both rational numbers and irrational number. Okay, we in first class we have been seen that real number will be represented by capital R. Real number contains both rational and irrational number. So rational number which are in fraction, okay, 2 by 3 like that, which is in fraction. Irrational numbers other than the rational numbers are irrational numbers which are presented in by square root, okay, and by the mathematical constants. So the real numbers which cannot be expressed in a roster forms sometimes, okay, sometimes we cannot express it in the roster forms, okay, because these real numbers are does not follow a pattern, okay, does not follow any particular pattern. So does not follow any particular pattern, therefore we cannot sometimes express in the roster form. So here we'll see the example for the finite and infinite set. So here in example 1, so here we if we put the value of here, the first condition we have to see that x is belongs to n. N is natural number, so a natural number contains other than 0, positive numbers are natural numbers, so on. So that one we have to understand. If we put the value of x here, so 0 we cannot put because 0 is a natural, not natural number. We put the 1, so 1 minus 1 0. So 0 into 0 0. So 1 is satisfied. And if we take two number, so 2 minus 1 is 1, and 2 minus 2 is 0 here. So this is also satisfied. Two number is also satisfied. If you put the 3, then 3 minus 1 is what? 3 minus 3 minus 1 is 2, and 3 minus 2 is what? 1. It will not 0. The other numbers are not 0, only 1 2. So we can express the one example in a set as 1 comma 2. So this is finite set. This is the finite set, right? So this is the finite set. So consider example 2. Okay, consider example 2 here. In example 2, x square is given 4. Okay, x square is given 4. So among natural number, which number is satisfied? So if we put the value of 2 here, it will be satisfied. So it is a set of 2. So then it is also a finite it is also a finite set, right? It is a finite set. And now we'll be seeing the third example. So third example, equation is that 2x minus 1 is equal to 0. 2x x is equal to minus 1 is 0. If you put the natural numbers 1 2 3 5, these are the natural numbers. So if you put the natural number 1, so 2 ones are 1 minus 1, so 1 remains. So 1 is equal to 0. Both are not equal, then 1 is not satisfied. And 2, if you put 2, then 2 4 minus 1 is equal to 0. 4 minus 1 is 3, so 3 is equal to 0. 2 is not satisfied. So if you put all the natural numbers, then this equation will be not satisfied, because this set does not contain an element. So this is an empty set. This is an empty set. We can say as this is the empty set. This is an empty set. Now next we'll be seeing the example 4. So example 4, x is a prime number. X is a prime number. So among natural numbers, So among there are natural numbers which are continuous. Natural numbers are continuous, 1, 2, 3, 4, and so on. And so prime numbers are 2, 3, 5, 7, and we can notify among natural numbers. We can notify the natural numbers which are continuous, which are because natural number are continuous, and then prime number among the prime numbers is continuous. Then for it is infinite set. We can say as this is an infinite set. Okay, see the example 5. So x is odd. X is odd means what? So here, and so in natural numbers, odd numbers we identify as 1, 3, 5, 7, so which are infinite, which are continuous. Therefore this set we can say as an infinite set. Okay, this set we can say as an infinite set. Okay, this is about finite and infinite set. Now we'll be discussing what is the equal sets. Okay, what is the meaning of equal sets? So equal set, as the name itself, we can identify equal set means what? There will be two sets or more sets. A and B are the, suppose take A and B are the two sets, and the A and B sets are equal. Only we are said to equal only when if elements of A present in the B, and if elements of B is also present in A. So then we'll be saying these two sets are equal. These two sets are equal. Otherwise we'll be saying as these sets are not equal. Okay, these sets are not equal. Okay, let's see an example. So we'll be see the example here. So let's see the example here. We'll be seeing the example. So take an example that let a 1, 2, 3, 4, and take set B as 3, 1, 4, 2. These two sets are equal or not? So these two sets are equal. These two sets are these two sets are equal. Why? Because so one is there. Okay, one is there. Two is there. Two is there. Three is there. Three is there. Four is there. Four is there. So we can say all elements of A are present in B, and all elements of B are present in A. Therefore, these two are equal. These two are equal. Okay, and take an example of here. Take example of another example. So here A contains 1, 2, 3, and B contains 2, 2, 1, 3, 3. So these two sets are equal or not equals? These two sets are equal. Why? Because don't count off this contains A contains 1, 2, 3, 3 elements, and it contains 5 elements. Then it will not equal. It is not a equal set. Don't count like that. Okay, this is an equal set. Why? Because only the difference is that here 2 repeats, and 3 repeats. But the it does it. But the element is contains in the B. So 1 is contained in B, 2 is contained in B, 3 is contained in B. So B is also contain of elements which are present in A. Therefore, A and B are equal. But usually when we are representing in a set, the repeated elements we cannot write. Sometimes we cannot write, but in your example, it may be given. It may be given to make confuse to you. So therefore, but mathematically we cannot represent repeated elements. Now we'll be seeing this example. So which are the set of pair of equal sets, and if any, give reasons. If okay, so we have to give the reasons. So first take here A. So A is contains only one element 0. Don't say as A is contains 0 means it is an empty set. Okay, it is not an empty set. It contains one element. A is equal to 0, and A is equal to 0. 0 belongs to 0 belongs to A. 0 belongs to A, and there is no element does not belong to B, C, D, E. Okay, there is no element So 0 does not belong to B, C, D, and E. Okay, here 0 will not there. If we put the 0, this equation will not satisfy. This equation not satisfy. And if we solving this equation, we will not get 0. Therefore, here 0 is not belongs to the B, C, D, E. We can say as A is not equal to 0. Then we can write as A is not is equal to 0. B, sorry, A is not equal to B, and A is not equal to C, we can write, and A is not equal to D, we can write, and A is not equal to E, we can write. Okay, B, C, D, E. A is not equal to B, C, D, and E. Okay, next take B. Okay, take B. So x is greater than 15 and x is less than 15. And then there is no number, the x number is present which is greater than 15 and less than 5. You identify this number which is greater than 15 and less than 15. There is no number present. Therefore, it is an infinite set. So it is an infinite set. It is infinite set. No, sorry, this is an not infinite set. There will be no element, there will be no number uh, we can identify it between the greater than 15 and less than 15. Then we can say it has an empty set. The set does not contain an element. It is an empty set, right? It is an empty set. There will be no element is present between this range, or which is greater than 15 and less than the 5. So it is an empty set, and there will be no empty set in among all C, E, and D. There will be no empty set. Then therefore we can, so B is empty set, and there none of the other sets are empty. Then for we can write as B is not equal to C, and the remaining. Okay, so remaining B is not equal to D, and B is not equal to B is not equal to E. Then take the example C here. So if we put the value of in C, so if we put the value of x is equal to 5, then this equation will be satisfied. So the value of C is what? 5. The value of C is 5. And what is the value of D? So what is the value of D? If we put the value minus 5 and 5, this equation will be satisfied. So here no the no particular condition is not given, x is belongs to natural number or integer number. Okay, so definitely it may be integer. So then we can take minus 5 and 5. So then therefore here C and D which are not equal form, because here minus 5 is there. 5 repeats. Okay, here 5 is repeating, but which is not but sign is different here. Minus 5, we cannot say as these two sets are equal, uh, because uh, because minus 5 is different, plus 5 is different. Okay, C is not equal to D. C is not equal to D. And the next, if we solve the equation, if this solve the equation if we solve the equation x square minus 2x minus 15, so what will be get? Will be get the value of 5. Okay, no, sorry, here we need to find root of the equations. We need to find root of the equation. So if you put the value of 5 here, then this equation will be satisfied. 0 is equal to 0 will come. Therefore e value is 5 here. E value is 5 here. Okay, and here E is equal to 5 and D is not equal to E. So D contains minus 5 and 5. E contains only 5. Therefore D is not equal to E. The only set matches, that is C is equal to E. E is contain 5 and C is contain 5. Therefore the only one set that matches is C is equal to E. Okay, this type of problem many times asked in your examinations. Try to practice of this type of problems. Okay, so next will we see the example here. Here, so these sets are equal, following sets are equal, justify your answer. So here set alloy is there. Okay, this is an X set. So this is an X set. So X is containing, if we write this in roster form, then A L O Y. So the L is repeats. We cannot write in the roster form, and B is contains the element of L O Y A, and L is repeats. L is, we cannot write that one. So here these two these two are these two are unequal because every element is there. A is here, L is here, O is here, Y is here. But these two elements are equal. These two, we can say as these two elements are equal. And we see the example of 2. So n is belongs to what? Z is what? Integers. Integer means it may be 0, negative or positive. Okay. So if we put the value of which are less than 4, this equation has to satisfy. Put -2, -1, 0 and 1 and 2. Okay, this will be satisfied this equation which are less than the 4, which are less than the 4. This is okay. If we write you see R means what? Real numbers. So real numbers, if we put the value of X is here, so rational number, then what is the value will be get? So if we put the value of if we put the value of will be get here 1 and 2. So take as here this set, take this set as A and this set as B, then value will be getting, put the value of 1 and 2 to satisfy this equation. If we put the value of 1, 0 is equal to 0 will come, and if we put the value of 2, then 0 into 0 is equal to 0 will come. So this set is not unequal. This set is not unequal because 0 is not having, and -1 -2 we are not having in B. So therefore we can say as A is not equal to B. Next topic we'll be going to discuss subsets and universal set. What is the meaning of subsets and universal set? Subsets. So as the name itself, we can identify subset means what? So subset means what? Suppose you take natural number which are infinite, okay, which are continuous. So which are continuous. So from the from the from the natural number we can write the, so from the natural number we can write a list of odd numbers, list of even numbers, and list of odd numbers, even numbers we can write. Okay, and one more is that subset is meanings what? So subset, I will give you example here. Suppose that uh, set A, take set A, that is set of all students, set of all students in school. Okay, in your school, take in your school, set of all students in your school, and B as set of all students in your class, students in your class. Okay, so a school contain classes, right? Suppose we take in class 11. So class 11, so the students class 11 which are present in a school, therefore we can say as B is a subset of, so B is a subset of A. Okay, the class 11 class students which are present, the elements of the class 11 students, the students of 11th class are those are present in a school. So, okay, if we consider school, then these students are students considered as students as an element. These elements will be present in the school. Then we can write as a B is a subset of A. B is a subset of A. So we can represent subset in this like, okay, ulta U. Okay, ulta U, not ulta, this as a, we can represent subset like by this notation. So sometimes this is also called as contain. Okay, contains in, and we'll be see here the definition of subset, the proper definition of subset. here we can write. So a set is, okay, a set A is said to be, a set A is said to be a subset of set B if every element of if every element of if every element of A is also an element of B. Okay, so this is the proper definition of a subset. So if A is said to be a subset of B, then if every element of A is also an element of B, means the element which are present in the B, therefore we can write A subset of B. The elements in A which are present in the B, okay, which are present in the B. Okay, this will be called as a subset. I will be give example here, then you will be understanding. Example here, example 1. So we know about Q is what? Q is rational number. Okay, Q is rational number. These are the standard symbols, and R is the real number. So what is the definition of real number? Real number is that which contains both rational and irrational numbers. Rational and irrational numbers. So then we can write as Q belongs to not belongs. Q is subset of R, right? Because Q is rational number. So rational number are present in the real numbers, because real numbers are the set of rational number and irrational number. And second example, A is a set of all divisor of 56, and B is the set of all prime numbers of 56. So if what are the numbers? What are the numbers? So what are the numbers if we divide by divisor by the 56? So we can 56 will be divided by 1, and it will be divided by 2, and it will be divided by 4. Okay, just a second. It will be divided by uh, 4, 7. Okay, like that we can write. So if 56 is divided by prime number, so prime numbers are 2, 3, 5, 7. So 2 you take here, 228 are 56, and then 214 is 28, and 2 sevens are 14, and 7 ones are 1. The prime numbers are here 2, 2, 2, 2, 7. So 2 is present here, and 7 is also present here. Therefore, we can say as here. So we can say as here, where B is a subset of A. B is a subset of A. So the prime numbers which divides the 56, which are present in the A. Therefore, we can write the B is a subset of A. And now, third example here, we'll be going to discuss that A is equal to 135, and B is equal to 135, and B is a set of natural numbers which are less than 6. Odd natural numbers which are less than 6. Odd natural numbers which are less than 135. Okay, 135. So these two sets are equal. These two sets are equal, and also subset. We can write this as A is a subset of B, and B is also subset of A, and okay, this condition will be satisfied only when A is equal to B. Okay, so A is a subset of B and B is a subset of A. This condition exists only when two sets are equal. When two sets are equal. Okay. In example 4, we'll see A E I O U, and B is A B C D. So these uh, here A these this is not in A is not subset of B, and if we compare both sets, if we compare both sets, if we compare the both sets, so here A is there, E is there, E is not there. Okay, E is not there, I not there, O U not there. So these are not in here, and these elements are not here. So when then we can say as, so the elements present in the A which are not in the B, and elements present in the B which are not in the A. A is not a subset of B, and B is also not a subset of A. Okay, this is an example of subsets. These are the example of subsets are not subset. Now we'll see the some example here. So then we need to here represent the symbols. So here pi is an empty set. A is 1 3 contains, and B is 1 5 9, C is 1 3 7 9. So pi is a B. So pi is B means, okay, it is a subset. Okay, it is a subset of B, because every empty set is a subset of respective every empty element. We cannot does not say that pi is having element which is not present in the B. Okay, so empty set is a subset of a another set. And AB, so AB 1 3, so it is not a subset, as 3 is not present in the B. And AC 1 3 1 3 is there, so this is a subset of C. A is a subset of C. And BC 159 159 159%. So B is a subset of C, we can write. Next we'll consider here subsets. There are two conditions in subset. We'll be going to discuss two conditions here. So one is that subsets of subsets of subsets of set of real numbers, subsets of set of real numbers. And another condition is that intervals, so intervals as subset of R. Okay, the first condition will be discussed here. Suppose I will write two elements here, two elements. So two elements belongs to real number. Okay, two elements belongs to real number. Then A is less than B. A is less than B. Then we can write here, this is in a set builder form. So y a y lies between A and B. Okay, y lies between A and B. Okay, so y is less than A and y is greater than B. So then we can write this in the form of we can write A and B. Sorry, I'm the second point I'm going to discussing here. Second point, that is intervals as a subset of R. And so these two conditions I will be right in the open form. So this is an open form. So the open form, and suppose if I will write, so if I will write the condition. Suppose if the condition is given, x is such that a equal to y and equal to b. B is equal greater than or equal to y, and y is greater than or equal to a. And this is the and this form of set, like this form of set here, end condition is there, means y is equal to a, it will be stop particular condition, and b is sorry, and b is having some end point. End point means if b is equal to y, then it will the interval will be stop. This is called an closed set, and this is called an closed set. So this we can write as a b. Okay, this we closed interval will be written in the square brackets, and here open interval will be written in the bracket, simple bracket only. Okay, this is the meaning of closed intervals and closed intervals and open intervals. Sometimes we write with a combination of closed intervals and open intervals. Okay, A, B. Okay, here this is a closed interval and this is a open interval. And some also we can write as like this. Okay, if we write this one in a set builder form, if we write this one in a set builder form, how we can write? So A. Okay, so these are in roster form, these are in builder forms. So here closed interval, open interval, and closed interval. Just identify the brackets. Okay, this bracket means square bracket. It means closed intervals. The simple bracket is open interval. So this square bracket will be represented by equal symbol. Okay, less than or equal symbol. If only one symbol is present, then it is open interval. Okay, understood? What is the open interval and closed intervals? And so here in this example will be this is an open interval will be in empty dots, here empty dots, and if these two dots are filled dots, these are filled dots, this is closed interval, and here one is filled dot and one is empty dot, then it is filled is closed and open and close. So this is an in the form of graphical representation. This is an graphical representation of a interval of subsets of real numbers. And now we'll be discussing the first point. Now we'll be discussing the first point. The first point is that is a the first point is we know about natural numbers, real numbers. Okay, natural numbers, real numbers, rational numbers. So these things we know. Okay, and sorry, we know about we discuss the first condition. We'll discuss here as subsets of what is the first condition? Subsets of a set of real numbers. Subsets of a set of real numbers. Suppose I previously I defined as n. N is contents of natural number which are continuous. So and but we can also possible to write we can from the main set. This is a main set or basic set. From this set we can I will write here a b c other sets from this set as a number of odd numbers 1 3 5 as a subset of odd numbers, and I can write as a subset of even numbers 2 4 6 8. Okay, so this is called as a subsets of a set of real numbers, and real numbers also contains both rational numbers and irrational numbers. And what is the notation of rational numbers? Rational number is q. Then we can write as a q is a subset of a real number. Q is a subset of real number, and here we can a is a subset of a natural number, and here and b is a subset of natural number. I can write right. Likewise, when we are representing mathematical the symbols each together, we can write. So n is natural number. So a natural number is a subset of z. Is it right? The natural numbers are positive numbers other than the zero. Z is what? Z is contains minus negative integers and zero and positive integers. So positive integers, these positive integers are natural numbers, right? So these positive integers are nothing but natural numbers. Therefore, natural numbers are a subset of Z. We can write, and Z is a subset of, and Z is a subset of, and And Z is a subset of what? Q is a subset of Q, rational numbers. Okay, Z is a rational numbers which are in the fractions. Which are in the fractions when we are 1 by 2 is what? Zero point 0.5. Zero point 0.5 will be in the integers. Okay, in the integers. And then next is Q. Q is a subset of R. Q is a rational number, which is a subset of R means real numbers. Real number contains both rational and irrational numbers. Suppose you take T as a irrational number, T as a irrational number. Okay? T is a representation of irrational number. T is a subset of a real number. And natural number, natural number is not a subset of rational numbers. Okay, natural number is not a subset of irrational numbers. Sorry, T is means what? Irrational numbers. Irrational numbers is a subset of real numbers, and natural numbers not a subset of a irrational numbers. Okay, next we'll be solving the exercise. Okay, here all the discussion of these topics: empty set, finite, infinite set, universal set, subsets. So now we'll be trying the exercise. We'll be solving the exercise. Okay, the exercise 1.2 and exercise 1.3 will be solving based on this concept. So first example is given here. So here in the question, here one question here in one question number one. So the first one is that set of odd natural numbers divisible by 2. So odd natural number divisible by 2. Here we need to identify which one is null set. Which one is null set? And odd numbers are 1, 3, 5, 7. These numbers are not divided by 2. It will be not divisible by 2. It is not divisible by 2. So there is no element present in the in a set. So we can say as, so this set does not contain an element. Therefore this one we can say as a, this is an empty set. This is an empty set, we can say. And in the second example, the set of even prime numbers. Set of even prime numbers, even prime numbers means we are having only one even prime number, that is 2. So here this set contains an element, but it is not a null set. It is not a null set. It is not null set. In third example, okay, in third example, x is a natural numbers. So here two conditions are given: x is less than 5 and x is greater than 5. And there is so there is no natural number is present less than 5 and greater than 5. There is no natural number is present between these two conditions. Therefore we can say as this set does not contain any element, and therefore this set we can say as a, it is an empty set. It is an empty set. It is an empty set. And fourth one is the yy is a point common to all two parallel lines. So two parallel lines means if take the two parallel lines, so y is a point common to two parallel lines. Here we between two parallel lines we cannot represent a point. So there are no points present in between two parallel lines. Okay, two parallel lines. So there will be no point if we write suppose here like this. If we write the two lines like the two lines are crossed each other, then we are having a point. But between the two parallel lines we are not having a no points. Therefore this we can say as there will be no points means this is an empty set. This is an empty set. This is an empty set. Okay, now we'll be solving the second problem. Second problem. So which of the following sets are finite and are infinite set? We need to identify which one is finite set and infinite set. Example 1, set of months of a year. So set of months of a years, it is a specific, well defined, means the we are having a year So here is having 12 months, here is having 12 months. So therefore this one is finite set. Okay, this one is finite set. And then second here, second one is 1 2 3 continue. So 1 2 3, these are the natural number, these are the continuous which are infinitely, so infinitely continue, therefore this is an infinite set. So this one is, second one is infinite set. And third one is that 1 2 3 99, and so 99 100. The here the range is well defined, here range is well defined, therefore this is a finite set, third one is a finite set. Don't get confused here. So here it is continuous, but numbers we don't, the remaining numbers are last numbers we don't know. But here three dots means what, the number continues here, 3 4 5 6 and up to 99, 99 100. And but the here set is well defined, here set is well defined, therefore it is an finite set. Okay, it has a specific limit ranges. This set is having the specific limit ranges, we are having specific limit. So here in third, here specific limit range is given, therefore this is an finite set. And now in the fourth, so fourth example, set of positive integers greater than 100. So greater than 100 positive numbers are, so there are n numbers of, or numbers are continuous which are infinite. So therefore this is an infinite number, this is an infinite set, this is an infinite set. Fourth one is infinite set. And fifth is what, fifth is what, so fifth is a set of prime numbers less than 99. So here less than 99, so the prime numbers means this is a specified range is given. So specified range is given, therefore this is an finite set. Okay, this is an finite set, this is an finite set. Okay, we next we go to the third problem. So third problem, so here we need to identify the set is finite or infinite. So set of lines which are parallel to the x-axis. So the first one is infinite. Okay, the first one is infinite. Why? Because so there are infinitely many lines between the two parallel to x-axis. Okay, parallel to x-axis. Suppose you take here, this is an x-axis and y-axis. So there are infinite number of parallel lines. Infinite. We can write a infinite number of parallel lines. Therefore, this is an infinite set and set of letters in English alphabets. So this is a finite set. Why? Because we know that the range of the alphabets are the specific range of the alphabet. There are only 26 26 alphabets are number words are there in the English alphabet, 26. Therefore it is in finite set. And set of number which are multiple 5. So multiple of 5, 5, 5, 10, 15, 20. This is multiple of 5. We can write in a continuous manner. Therefore this is an infinite set. So this is an infinite set. So this is an infinite set. And fourth one is the set of animals living on the earth. Okay, fourth one is, so fourth one is the number is high. Here the number is high, but it is possible to count the animals. But we are having the number of animals. We can say that in our Karnataka, this number, this 400 tigers are there. Okay, this much of animal, this much of tiger is there. This much of elements is there. We are having count of that. So, but numbers are high. Therefore, we say as this some finite number. Okay, some finite number. This is a finite set. Okay, set of circle passing through the origin. So, the fifth one is that, so fifth one is a finite set. Okay, fifth one is a finite set. No, sorry, fifth one is fourth one is a finite set, and fifth one is a this is an fifth one is a infinite set. Infinite set. Why? Because there are infinite many circles passing through the origin. Okay, suppose you take here this origin is there. So o origin. So by passing this origin we can draw the many circles. Okay, I can draw like this, and I can draw like this, I can draw like this, I can draw like this. So by passing these origins I can draw many circles. So therefore this is an infinite set. Therefore this is an infinite set. Okay, understood. Go to the next problem here. So here we need to identify which sets are equal or not. Okay, A and B, compare A and B. So A is present here, B is present is here, C is also there, D is also there. Then A is equal to B. Okay, so compare 4 is there, 4 is there, 8 is there, 8 is there, 12, 12 is not there, 16 is there, 12 is not there. Okay, 12 is not there, therefore A is not equal to B, we can write. So third one is that, third one is 2, 4, 6, 10, and positive even integers and which are less than equal to 10. So we can write third condition is here. So 2, 4, 6, 8, 10, and B is what? So positive even integers which are less than or equal to 10. 2 less than 10 means less than or equal to 10. 2, 4, 6, 8, and 10 we can write. So A and B are equal. A and B are equal here. Then fourth one is what? Say multiple of 10. So A is multiple of 10 means A set we can write as 10, 20, 30, multiple of 10. 10, 20, 30, and 10 ones are 10, twos are 10, threes are 10, fours are 40. We can write like this. And B is what? So 10, 15, 20, 25. It is a multiple of 5. 5 twos are 10, 5 2 threes are 15, 5 fours are 20. It is a multiple of 5, it is a multiple of 10. So therefore it is not a, the sets are not equal. The sets are not equal. Go to the next problem here. Following pairs are sets. The following pairs are equal. Give the reasons. So A and B, set A contains 2, 3. Here x is a solution of x square 5x plus 6. If we solve this equation, so first problem is here A is 2, 3. So what are the values of B? So, okay, if we solve this equation, if we solve equation, what is the value of x will be get? So here x square into 6 is 6x square, and if we multiply this 3 2s are 5. Okay, here means x is equal to 2 3 we'll get. Okay, x is equal to 3. Then therefore A is equal to B. A is equal to B. And next second one is, so x is a letter of follow. So x is a letter of follow. F O L L L repeats, we cannot write O W. And B is wolf. O W O L and F. Okay, W is there, W is here, O is here, O is, O also we cannot write here because it repeats. L is here, F is here. Okay, these two sets are equal. You can write these two sets are equal. Next we go to the number 6. Here here we go to the problem number 6. Which sets are equal sets? Okay, we need to compare all these sets and we have to write which equal set are not. Okay, if we compare A with the B, 2 4, 2 is there, 4 is there, 8 is not there, therefore A is not equal to B. A is not equal to B. And if we compare the B with the C, so B with the C is not equal. B with the C is also not equal. B to C is not equal. If we compare C with the D, C with the D, C also not equal. C with the D is also not equal. If we compare E with the F, so E with the F, this is also not equal. If we compare E with the G, E with the G, so E with the G, So these are then equals. So okay, e is equal to 0. Here minus 1 is there, minus 1 is here, 1 is here, 1 is here. Okay, but here don't compare about order. So order it may be here minus 1 is at the first, minus 1 is in the second. Don't compare the order. Okay, so this is a is equal to a is equal to g, and f, compare f with the h. F is not equal to h. With the only set will get p is e is equal to g. Next we'll be solving the exercise 3. So based on the concept of subsets and universal set, subsets and universal set and intervals of real numbers, the two condition of real numbers we have been seen. Based on that we'll be solving this exercise. So here first question, in that first question we need to uh, symbolize that it is includes in the subset 2 3 4. 2 is there, 2 3 is there, 4 is there, 2 3 4 is there. Then this is a subset of this. We can write this is a subset of this. And ABC, BCD, this is not a subset of. And then X is a student of class 11 of your school, and X is a student of your school. So this is a subset of. Okay, this is a subset of. This is a subset, example of subset. And next we write third one is third one is subset, and fourth one is also subset of subset, and fifth one is what? So triangle and rectangle both are different, therefore it is not a subset. And the sixth one is what? So sixth one is not a subset. Equilateral triangle and the triangle in the same plane, so those are not equal. And seventh one is what? Seventh one is a subset. So those are even natural numbers, 2, 4, 6, and 8. These are present in the integers. So integer what? Integer contains positive number. Integer contains positive number, negative number, and 0. But these even numbers which will be present in the integers. Therefore, we can say as it is a subset. It is a subset. Now come to the second problem. So in this problem we have to determine the statement is true or false. That one we have to determine. The first one is a b elements which contains in b c a. So a is there, okay, and b is there. Then so this set is subset of this set, but it is not given here. So then it is so this is a false, right? This is false. So it is a not a subset of this, that is the meaning, but it is a set, then for it is a false. And ae, so the x is a whole in English alphabet. So x is whole in English alphabet means what? We know that alphabets are vowels in English, that is a e I O U. Okay, so A E I O U, then means here A is there and B is there in this set. Okay, in this set A is there, B is there, then it is subset of this set. Okay, then it is true. It is given as a true. Okay, then next is that 1 2 3. So 1 is there, 2 is not there, and therefore 3 is there, but 2 is not there. And here therefore it is not a subset, then it is a false. It is, the statement is given as a false. So it is a subset, then it is true. The given it is a subset. And here uh, this is not a, a is not, a is belongs to in this set, but here a is given in a set. Okay, here a is given in a set, it is a false, because the element has to this one has to be right. Okay, this one has to be right, like this, okay, uh, a b c. Okay, this is the meaning of that. But here it is given in a set. Okay, this is wrong. Okay, and then next sixth one is that even natural numbers less than 6. Even natural number less than 6 is 2 4. and x is a natural number which divides 36. So here a set of this and another set is dot. So another set is given. This symbol is belongs, I am writing here, and natural number which belongs to divides the 36. So it will 36 will be divided by 1, 2 and 3 also, and 4 also. 4 also it will divide, and 1, 2, 3, 4 and so on. It will be divided by other numbers. But here 2 is contained in this, 4 is also contained in this. Then therefore this is a correct. This is a true. This is a true statement. Now come to the next next problem. Here we have to identify the statement is given is correct or incorrect. So if it is incorrect, then we have to give the reason. Okay, if it is incorrect, then we have to give the reason. So the problem one is given. So problem one is given. So A is means what? A is this set. Okay, 3 4 is in the in the in the set, in the basic set is there, but it is not correct because 3 4 is in a one element here. 3 4 is given in a one element. 3 4 is given in a one element here. So then here it is, this is not written in a this is not written in a set, because we are when we are saying subset, then this is also set, this is also set, but this is not a this is not a set here. If suppose this is this has to be right in a set, means we have to write in curly bracket of 3 by 4, because it is in one element, and curly bracket we have to write. So this example has been given here. Okay, third one. So now we can say this is a correct statement. This is a correct statement. Okay, this is incorrect. This is incorrect. We have to give that curly bracket of 3 by 4 is not a set. Is not a set. Therefore it is a incorrect. Therefore it is a incorrect. We have to give the reason like this. Okay, next here 3 4 is belongs to a. So 3 4 is belongs to a, it is there, but yes, this is correct statement. 3 4 is it is an element. Okay, it is not a set. It is not a here it is not a set. It is not a set. It is a element. It is a element. It is an element that is it belongs to a, therefore it is a correct statement. Okay, don't get confused of that. Here in curly bracket, the here the in curly bracket given, therefore this problem is very important. It is sometimes it is a confusing problem. Okay, and here one is belongs to a, this is correct statement. Okay, this is correct statement. One element is belongs to a, and here one is a subset of a, this is wrong statement, because here it is not written in a, one is not written in a set. Okay, use this, you write as this is an incorrect. Okay, this statement is incorrect because you write just like that, because one is not written in a set, one is not written in a set. Okay, so for incorrect statement we have to give the reason. Okay, and the here 1 3 1 to 5 set, 1 to 5 set, it belongs to it is a subset of a, it is correct. It is a statement is correct. And next is seventh one. Here seventh one we're going to discuss. So seventh one we're going to discuss. So seventh one is given 1 to 5 is belongs to here is belongs to, this symbol is belongs to, and this symbol is a subset. So see, this is a how they are giving the confusing problem. So 1 to 5 is belongs to a. 1 to 5 is their elements, but is that it is a set, it is written in a set. So it is written in a set. So it is written in a set. So therefore it is a incorrect statement. So incorrect statement, it is written in a, it is written in a set, and it is written in a set, and it does not belongs to the set is does not belongs to a, the set is does not belongs to a, like that we have to write. So therefore seventh one is incorrect. Seventh one is incorrect, and eighth one is, now we discuss. Eighth one is 1 2 3. So eighth one is very interesting. So 1 2 3 is 1 2 3 elements are there, So 1 2 3 elements are there. Okay, 1 2 3 elements is there. Just okay, 1 2 3 elements is there. But the thing is that, so but it is not a subset of A, because A is independent here. Okay, we cannot write 3 and 4, we cannot write 3 and 4 here as a independent. Okay, so here uh, I will write once more here. A is equal to 1 2 uh, 3 4 and 5 is written here. So here 3 4 we cannot write as independently. We cannot write it as independently. Here it is written in 8th problem. You just see here in 8th problem it is written. Therefore, it is incorrect. It is a incorrect. You just mention that why it is incorrect. So 1 2 3 is not eighth one. So eighth one you have to write 3 is a not independent, and therefore we cannot write like that, because therefore this is an incorrect statement. So ninth one, we come to ninth one. So ninth one is empty set is belongs to empty set is belongs to A. So belongs to A. uh, it is an incorrect statement. Ninth one is incorrect statement, because pi is no containing, so no elements in empty set, no elements in the empty set, so therefore it does not belongs to A. It is incorrect statement. But 10th one is that pi is subset of A. Yes, because every empty set is a subset of basic set. Every empty set is a subset of basic set. And 11th one, so 11th one we can write as, so again the empty set is given curly bracket, and it is belongs to A. Yeah, this is we can write. So pi is also independently we can write, or within the bracket we can write. Therefore this statement is correct. This statement is correct. Okay, so next we come to the next problem. So fourth one we have to write in the subset forms. These things we have to write in subset forms. So I am writing A in the form of subset. What are the subsets of this? So empty set is a subset, and also A is also subset of this given problems. And AB, so for AB, what are the subset? One is empty set, and one we can write independently, AB, and we can write independently, and also both together we can write. Okay, next is third one is what? So third one is 1 2 3. What are the subset of this? One is empty set, and one is set of 1, 2, and the set of 3. And we can write both together. How we can write? We can write 1 2, and set of 1 3 also we can write, and set of 2 3 also we can write, and a set of 1 2 3 we can write. Okay, these are the subset of the third one. And fourth one is pi. So for the pi empty set, the only one set is the only one set is empty set. The only one set is empty set. So come to the next problem. So we have to write these things in a interval forms. So in interval form, first one, so first you know about uh, open interval and closed interval. So open interval will be written in the like this bracket, okay, like this bracket, and closed interval will be written in a square bracket. Okay, this is the difference between open interval and closed interval. And one more thing is that, so closed interval we will be used when when the symbols are like this: greater than or equal to, less than or equal to. Okay, and for open interval we'll be write the we'll be writing when the symbols are greater or less than. Only one symbol is there. Okay, the idea is clear here. So now we can express in a uh, interval we can express. So minus 4 is a open interval, and here equal to greater less than or equal to given, then it is a, so it is a closed. Okay, next second one we can write as Second one here is open and here is also open. Both are open. Then we can write as minus 10 and minus 12 and minus 10. And third one is here. It is open. Not open. It is closed. So it is closed and here it is open. Then we can write here open. Sorry, close. Here close we can write. Here close we can write and 0 and here here open. 7 is open. And what about here? It is closed and it is closed. Both are closed. Fourth one we can write as 3 comma 4. Right. Next, come to the next problem. Sixth one. So sixth one is here we need to write in a set builder forms. Okay, the given problem we have to write in a set builder form. So minus 3 0 here open is there and close and here open close and here close and open. Okay, then we can express this one. X is such that, so x is such that, so minus 3 open, then x open. Okay, like this we can write. Both are open. Then like in the second one we can write as, so x is both are closed. Then we can write 6 less than or equal x and x less than or equal to the 12. Okay, to the 12. So we are writing in the set builder form. Okay, the intervals we are writing in a set builder form. And next one is one is open. First one is open. Then we can write here x, and second one is close. And the fourth one we can write as, the first one is close. First one is close and second one is open. Okay. So this is the problem of that statement. Okay. So, and next one we need to identify this is universal set or not set. So universal set means what? So universal set means we are having a set. So when it is the set basic set, when the basic set is derived among from the main set, when basic set is derived 1 2 3 sets ABC or ABC set. So suppose I will give you example here. Natural number contains positive numbers. Okay, positive numbers, so on. So from this I am writing a even natural numbers as one set. A is equal to even natural numbers. I will set B I will write as a odd natural numbers. Odd natural numbers. Therefore, it is a universal set. Then we can say as n is a universal set. So then first problem is a set of right triangles. So right triangles means we are talking about triangles. So triangle, this is a triangle. So triangle contains many right angles. When we are deriving this one, so we are having 90 degree here. So this part will be called as a triangle. So 90 degree part of the triangle will be called as a triangle. So triangle contains many right angles. Therefore, it is a universal set. First one is universal set. Universal set. And second one is set of isosceles triangles. So we are talking about triangles. So in triangles, we'll be having many set of triangles. Many set of isosceles triangles. Therefore, it is a universal set. We can say as, so this is also universal set. Come to the next problem. So next problem is given three set, 1 2 3. These three sets are containing in these sorry, containing in these. So that one we have to write. So 0 so we have to write that one. So these three are there here. So 1 is here, 2 3 is here, 5 is here, so 2 is here, 4 is here, 0 is here, 0 is there here, and 2 is also is here in this set. 4 is 6 is there, but 8 is not there here. So 8 is not there. We can write this. This is not a universal set. Then we can write that this is not a universal set. That is, this is not a universal set. And pi, so pi is empty, so it does not contain a element. Therefore, it is not a universal set. It is not a universal set. And here next we can see the 0 1 2 3 4 5 6 1 3 5 2 4 6 and 0 2 4 6 6 8. All are these elements, ABC set elements are there in this set, therefore this is a universal set, we can say this is universal set. And what about this one? So 1 2 3 4 5, but 0 is not there here, 0 is not here, therefore this is, we can say as this is not a universal set, this is not a universal set. Okay, so the exercise 1.2 1.3 are covered. So next class we'll be seeing the remaining topic, that is Venn diagrams, and based on that we'll be solving the exercise. So, and after that we'll be solving some interesting numericals or interesting exercise problems, which is given as miscellaneous exercise. Some important problems only will be going to solve. So another 1 or 2 classes are required. Okay, thank you for watching. Please subscribe the channel and share to your friends and hit the bell icon for the notification. Thank you very much.